Okay, so we are Team 5 and we're going to expose our project, which is a PLA Composer. The PLA Composer is basically the remaining of PLA from 3D printing. We are going to merge it with a Composter, and as we can see here in this diagram, and through the good requirements of temperature, humidity, and chemicals, through time, we're going to be able to make the dirt of the Composter able to grow a plant. So our main part of the sketch, we got the case and we got our first wireless connection, and we made our prototype using Fusion 360. And our main schemes of this case are to have these Arduino electronic device connections, where we are going to take the temperature, humidity of the grass, of the dirt with the PLA, and we're going to evaluate how to induce heat to it, because we have to evaluate the right requirements of the PLA Composer. We need to have different type of humidity and the right quality of temperature. So when the temperature drops, using these electronic devices, we're going to be able to know in real time using Wi-Fi wireless Arduino devices. So when we know when the temperature drops, we're going to be able to induce heat contact to the PLA Composer to make it to be more good with the requirements of it.
We will need to work around some restrictions. The main one is monetary. We need to be able to build this cheaply and be able to sell it in a market that it's aimed at individuals to have them in their homes. So it needs to be relatively small, portable, cheap, easy to assemble, because it will probably be easier shipping to be disassembled, disassembled. And we'll need to work with some sensors that are capable of withstanding the process of composting done within the box. Also, what we can accomplish a functioning product that would be or should be able to decompose polylactic acid in a matter of a few months. The only byproduct, organic byproduct, would be basically plant fertilizer. So you can easily dispose it wherever you want.
Okay, and who's going to be our customer and our user? So our customer is going to be small businesses, a person who owns a 3D printer at home, and schools. And our users, it's the same as our customers, but people that like to recycle and want to help the environment. Another important point is that once a customer has our product, it's going to be big, as my teammate Santiago presented. So they're going to have a warehouse or a place on the floor where to place the PLA Composer.
Well, what has been done so far? We had a prototype sketch, which we already presented, our first prototype, CAD iterations and electronic components, as well as setting up our restrictions. Then the next one, please.
What has to be done? Start the prototype, make an MVP market test, edit, final presentation, and then develop the experience report progress. So first, the prototype, the key points to address are define a budget. So making a prototype should be cheap, so we can test and test and test, obtain the materials that we need and we've assigned to the design. Then build the prototype so we can test it and change it if we need it, and test it. So the MVP market test is going to be a key point for this, because first we need to find people that are in our market segment. Then after the interview, we need to define what needs to be improved and what should we focus based on the interview's results.
Okay, so these are biography based to complete the PLA Composer, and thank you for watching this report.